I'm Krista Campbell. Thank you for joining us today for Improving Operational Efficiencies with Location Intelligence. In today's webinar, you will learn how GIS-based solutions have improved operational workflows, resulting in high-quality data available across the organization, saving time and money. Eric Garcia, Operations Manager at Camrosa Water District, will be sharing details of the challenges faced prior to implementing ArcGIS, as well as the benefits gained after. I hope you enjoy the webinar. Let's get started. Our topics today: why ArcGIS, how does ArcGIS support operations, and operations at Camrosa Water District. Why ArcGIS? ArcGIS is a modern web GIS platform. Many of you have learned from our previous webinars that ArcGIS enables a system of record, a way to manage your authoritative data, a system of engagement, providing staff access to data and sharing it across your organization, as well as a system of insight, providing analytics that turn your data into valuable information. Although this is important, it's not what's important to operations. And what I mean by that is that the details of the technology is not the focus. What they need are the benefits that result from the technology. Eric Garcia, today's presenter from Camrosa Water, and I have had many conversations since we first met. I would say that we're friends. And one of the things that he said to me recently, it really stands out. He said that in the past 9 months, implementing ArcGIS for the operations team has resulted in 39% more work being completed with the same budget. This is the why. How does ArcGIS support operations? Operators are responsible for delivering safe drinking water on time and on budget. Before we get to Eric's presentation, I'm going to highlight how ArcGIS helps operators to do this in a couple different ways and supporting them by providing tools that make a difference in their daily work. There are many aspects to system operation that GIS supports, primarily knowing where your infrastructure is. This is really important. Having a complete map of your assets is important, enabling workflow efficiency. In addition to location, there's record keeping, maintaining records on system changes, meter readings, maintenance activities, inspections. GIS is an amazing system of record. It provides an easy-to-use platform that manages data collection, editing, and sharing. It excels as an authoritative data repository. Preparation and execution of a maintenance plan. ArcGIS brings your data to life. It provides insight that supports data-driven development of a plan, and its easy-to-use applications help to execute that plan. Creation of standard operating procedures. Again, knowing where your assets are. This is very important. Sharing this data and then using analytics can help you clearly define standard operating procedures. An important responsibility is regulatory compliance. All water service providers are regulated at the federal level by the U.S. Environmental Protection Agency and at the state level by various state health and environmental agencies. EPA rules also set water testing schedules, methods that water systems must follow. GIS is a mapping and analytics software. Storing sampling locations, for example, in a GIS provides a visual representation, a map, of sampling locations throughout service areas. You can then use this information with routing tools to determine the most efficient routes for visiting these locations. With your data stored in a GIS, you can quickly report the number of samples taken, when the sample was taken, and where they were taken from. This is a specific type of regulatory compliance, but there are many regulations that water utilities face. Another example is the Clean Water Act's National Pollutant Discharge Elimination System program. This regulates point sources that discharge pollutants into waters of the U.S. Did you know that Esri customers are using Survey 123 to support data gathering and reporting for their MPDES permits? Communication is vital to success. Communicating with office staff, field staff, and the management team can be challenging. Operators need information at their fingertips to save them time calling to the office or driving back to the office. Having information about system assets, including attachments such as as-built drawings, photos, and video, can save a lot of time. Supervisors and managers need to know the status of the work being completed. They need to know if they're on schedule to meet their goals. Managers and board members often require system performance updates. In addition to field and office staff, supervisors, managers, and board members, it's also often necessary to communicate with cross-functional teams like engineering. ArcGIS includes a suite of applications that help to communicate, to share information across your organization. One example is dashboards. Dashboards can be used to share real-time work being completed in the field. It can share sensor readings, service requests, and more. Each dashboard can be configured to show what is important to each stakeholder. The results of analytics can be shared within a dashboard. You can show analytics as charts, graphs, and maps, making communications with managers clear and concise. In addition, easy-to-use tools like our web app builder provide a way to create applications that are configured specifically for your needs within operations as well as across your organization. One last app I'd like to mention are story maps. They can also be used to engage stakeholders by providing information paired with beautiful images, maps, and even video. So why ArcGIS? It really comes back to this quote. ArcGIS is enabling workflows that are saving time and money. So I know you're all excited to hear Eric's story. I have one more item before we get to Eric. We're going to have a polling question. If you could just take a second to answer the poll, are you using ArcGIS to support operations? Yes, no, or you don't know. It's just going to take a second to get our answers in. It looks like a lot of you have already answered. We'll wait one more minute. Are you using ArcGIS to support operations? Yes, no, I don't know. Wonderful. It looks like we have about 77% attendees saying yes, you're using ArcGIS. That's amazing. And we have about 18% that said no. A couple of you aren't sure. So thank you for answering the polling question. As I mentioned, our presenter today is Eric Garcia. He is the Manager of Operations at Camarosa Water District. Eric, we're going to pass it to you.
Hey, Krista, how are you doing? Can you all see my my screen?
Yes, we see it. Thanks, Eric.
Okay, well, without further ado, let's go ahead and start. So as Krista mentioned, my name is Eric Garcia. I am the Operations Manager here at the Camarosa Water District. Quick background about me. I've been the Operations Manager for about 1.5 years here at Camarosa. Prior to that, I was a Air Force military officer running all sorts of different operations all over the world. So I was able to transfer that knowledge into the I have now, which you'll see today. Okay, so a little bit about Camarosa. We are a decently sized water district in Southern California, in Ventura County, about 45 miles north of Los Angeles. And we have 3 different water systems to include potable water, non-potable, and wastewater. We deliver services to approximately 35,000 people and deliver about 14,500 acre-feet of water. So you get an idea of our size. We have 26 full-time employees, and O&M is about 12 of that. Represents 12 of those individuals. And a couple other stats, we have about 8,000 or 8,400 service connections and a little over 200 miles of piping. So objectives, what I hope you get from this today is I'm going to use a very specific case study, what I refer to as my preventive maintenance plan. And actually, I should caveat that it's our preventive maintenance plan. So I'll build a little bit of background on that, and I'm going to specifically talk about how we integrated the GIS portion of that into that plan and how the GIS made it possible. I'll also talk about some other GIS enhancement that we're able to get because of the work we did, not only from the PM plan, but some crosstalk with our staff, GIS staff, and I'll finish up with some results and some conclusions. So the bottom line, as Krista alluded to earlier, my role here really is to deliver water on time, keep the water flowing on time and on budget, or on schedule. But what does that mean? So there's obviously a lot of ways to do that. And as I came into the district, again, having relatively little experience in the water industry, I had to rely a lot on my staff and I asked the basic simple question: where are we now and where do we want to go? And the overwhelming response I got, which seems to be pretty concurrent with most of the water industry, is we are very reactive, and I'm sure most of you out there can relate to that. We're constantly being firefighter, where our staff, being motivated that they want to be much more proactive, and they want to, in the words of my operations superintendent, take back control of our assets and take back control of our district. So that's the goal. Well, the question is, how do we get there, right? Well, one way, what we developed was we developed this plan that we call a preventive maintenance plan, and I'm sure many other districts have something similar in place. But I want to kind of the emphasis today is how the GIS was a key tool that enabled us to arrive a solution to this problem. I like to kind of equate the GIS, as you may see, you might wonder why there's a paint and canvas on there, because I think it's a good analogy where the GIS really is kind of like a paintbrush, right? If your district's the canvas, data is kind of your paint, and the GIS is your paintbrush. It really allows you, it's a tool to let you do what you need to do, but it's still up to the user, the artist, which is the district, to make the picture happen and to paint it. So a little bit about our relationship here. And again, this is just kind of to emphasize that our GIS really is a foundation from a data management, data collection standpoint that really integrates across multiple other spectrums. And because there's a commonality between all these different areas, not only functional areas, but also in data collection and software implementation, it really is kind of the keystone that allows us to do all the things that we've been able to do in the past, really the past years, where it's really kind of taken an exponential curve. So, this is just our structure. There's many more out there, and all have their merits, but this was one that worked for us, and I'm thoroughly convinced that the GIS is the keystone to do that. Again, when we talk in engineering, we're talking to the asset management system, the financial system, customer service system, and perhaps more importantly, it's the key link that allows data to pass to and from our GIS to our asset management into and out of the field, and you'll see that here in a second. So again, I'm going to talk to a specific case study with our GIS, and this is how we've used the GIS in the development of our preventive maintenance plan. So in order for you to understand that, I think I need to go into a little bit about the background of what it took to develop the plan. So nothing cosmic here. We devised a game plan to do that, and this is pretty, any of you familiar with the engineering method or scientific method, it's a pretty standard process. Also with a Six Sigma DVAIC, it's very similar. We got to define the problem, analyze the problem, develop a game plan, execute the problem, and then assess it at the end. And of course, it's iterative, right? Where our GIS really came into play was really these four sections here, right? Analyze, plan, execute, and assess. Because again, it's the tool that allowed us to get the data to figure out what direction we wanted to go in, and our speedometer of how we're getting there, right? And again, our problem was we wanted to go from reactive to proactive. So how did we do that? Well, the first part of that analyze phase that I alluded to earlier, we had to develop frame the problem in a way that we can wrap our head around. So really that meant balancing the risk of failure to act in preventive maintenance versus the cost. So the resource cost really came down to the only three resources we have, or in my opinion, any organization has, is time, money, and people, right? And sometimes you can exchange those one for the other. If I pay a contractor, it might cost me more money, but I might save some time, etc. But in reality, as managers, that's really my main job, is to manage those resources effectively to the best prudent availability for the public's trust. Well, on the flip side of that, you have the risk. Well, what is the risk of failure? That's how we kind of frame this problem. If we fail to do something, what risk are we taking to do that? And then we had to go through and quantify that. Once we were able to do that, we did that for all our assets. Now I want to point out, this was the result of it, and this is what I call the game plan. This is our preventive maintenance plan. This is a simple Excel spreadsheet. Now this is just a snippet of it. The full preventive maintenance plan is much more Well, it's much longer, much more in depth, and there's a lot of things, a lot of calculations kind of going on behind the hood there. But for all intents and purposes, this was the simplified version of that. What the GIS was able to do was it was able to provide us the data. So this was the game plan here, the scoring and the identify and define, which is basically gathering all our assets. But it was able to get us the data to actually calculate our status and track our KPIs for the district. Then came the fun part, the execution. As you see with this fine picture here, this is what we're trying to prevent, right? Because we all know that maintenance workers, when they're bored, they'll find something to do. No, just kidding. That's a little joke here. But really, the execution phase came in was huge. Well, what we determined was in order to get that execution piece to function appropriately, we needed to track our status. And we spent a lot of time searching for the right software to track that status, because we even fiddled around with the idea with tracking it, you know, by some kind of pencil paper, an Excel format, various different methods. But we felt that because we had a decent GIS backbone in place already, we already had the licenses for some of those needs, that this was going to be the best way to keep an organic story, a logbook, if you will, of our current status of the PM plan. And the other thing I need to caveat pretty heavily too is it was by far going to be the most field-friendly platform. There are other asset management tools out there. Some of them are more of a financial base. Some of them are more of a workflow, and others. But from our experience, the GIS was the most field-friendly. And of course, we wanted to prevent poor data coming in, because garbage in, garbage out. So if the field workers aren't using the application, they're not using your methodology, or it's painful to do that, it makes it very difficult to collect the data in the first place, which makes it very difficult to do anything else, quite frankly. So that was the first step. The second step was kind of alluding to that point. It does require a common operating picture. And by what that I mean, you need a good communication tool that can concisely, correctly, and accurately demonstrate your current status to all your employees with minimal oversight, which is again also what the GIS and subsequent the additional platforms that we purchased were able to do. And of course, going back to that slide from earlier, it's a continuously iterative process where you need that feedback, which only further exacerbates the need for those further things of good asset management, good communication, good common operating picture. So a little bit about our GIS. This is kind of a snapshot. I'm going to quickly go over to the live link here from our system. So this right here is an actual live link from our GIS, and this is on top of a third-party platform. So you can see that that's our infrastructure, and then this is a third-party platform that provides the work order history and also integrates basically as the entry point for the data for the operators. Now this links directly back into our Esri Geodatabase, and it builds on top of that, right? So as you can see here, this is not our entire work order or our entire preventive maintenance. This is just a snapshot of the past 90 days. If we did the full year, it would kind of flood the picture here. But I'm just going to go in so you can kind of understand. You know, we have a very diverse, it's very spread out infrastructure spread across 30 square miles. I'm sure many of you out there have even larger districts. But with this system and this capability, we're able to very quickly see what work is being done where, when, and to what effect. And in fact, if you know how to read these symbols, I can tell you that, for example, these little squares mean the work is complete, and these little triangles means it's in progress. And not only that, I can very quickly look at the status of anything too. And there's a bunch of other things you can do. You can look at different reports, etc. But for the purpose of this presentation, I'll keep it kind of simple. So I'm just going to zoom in here so you can kind of take a look. This is actually our sewer line, and each one of these little dots here, these squares, is actually a work order that was done on a manhole rehabilitation, which is part of the preventive maintenance plan, where we rehab our entire manhole and recoat it with a polyurethane coat. So I can open up this work order, and it's pretty quick and simple and easy to do that. And it has pictures and whatnot. It loads here. So as you can see, that's a picture of a manhole that was raised not fairly recently. It's got a fairly robust work order history. You can assign it to different users, whatnot. But in addition to that, the key is it's physically attached to our GIS, which means it goes back into our GIS. It's part of our Geodatabase. It has a forever record, and it allows us to do complicated data analytics later down the line, if and when we ever choose to do so, which of course is going to save us time and money. The other thing you could do here is I'm going to quickly turn this off. And I can go in, and because everything's attached to the GIS, I can find something based on an asset ID. So I can very quickly query information. And by the way, everything you see here is also available in the field to all the operators at all times. So I'm just going to open up here, find information, and there's a mobile version which is a little bit easier to see. So that's that same work order right here, and that gives me a working history of everything that's been done on that. This particular one has only had that one done on it so far, so there's only one on it. But if I go to this one, it will give me that work order history. Oops, wrong one. Okay, of course, it's a problem with live presentation, but you get the idea that, again, it's all attached to our GIS. And one of the other advantages for the operators really like is because it's tied back in our GIS, and our GIS is talking to our engineering database, it gives them the ability to have live links to all of our as-built. This is a particular as-built for that project. This particular one happens to be for the diversion right there. So going back, all right, so you can see the power of that and what that's able to do for us. But we didn't stop there. Because we had this GIS kind of a renaissance, we quickly realized that by having a strong GIS meant that our operators could have more capabilities in the field. And so we actually started monthly crosstalks between our GIS staff and our O&M operators directly. Well, that generated a lot of good ideas, and a lot of the operators say, hey, you know what, this is something that I would like to have and would make my life a lot easier because it would save me trips back and forth. Like, for example, the as-built is one of them, right? The other one is this redlining function. The converse was true, where our GIS staff then came back and said, hey, you know what would be useful? You're my eyes and ears out there. You're the best one that knows what's going on. It'd be useful if at the time you can integrate that back and send information for any changes that you would request back into the GIS, which we actually did. And we actually used Collector to use what's called a redlining function and reverse work orders. So we're actually sending work orders from the field back into our GIS staff to make updates and changes so that our GIS can be organic and fluid and always accurate. And I'll show you a quick picture of what that looks like here in the next slide. And we'll talk about that here in a second, because the other thing that allowed us to do was it allows for post-processing on the analytics from the GIS team and the GIS staff. And of course, because it's an enhancement to legacy capabilities, such as being able to produce more accurate atlas books on a much quicker time scale, the operators are big fans of it because it doesn't take away their old capabilities, it builds on top of it. And I'm going to go here. This is a quick snapshot of, this is actually from Collector, where you can see that's kind of the work order that at the bottom. Those are multiple work orders of things that the operators have noticed that are inaccuracies in our GIS because of whatever reason, either it was input wrong or the source document being the as-built was incorrect. And then where he's able to capture that and then make changes appropriately to get a more accurate atlas. More accurate GIS, Geodatabase. So who really cares, right? we talked about the game plan, how we're able to do it. Well, here's the crux of it. Operators really appreciate it, at least my operators did. First of all, they're very innovative and very bright individuals, but they realize that this really can save their time, and it's easy to use, right? It provides real-time engineering data to them in the field whenever they need it at their fingertips, and it also provides a real-time maintenance history whenever they need to or want to, which really helps them troubleshoot things in the field in real time. In addition to that, it also operates some, there are some optimizations that you can do, like route optimization, et cetera, because you're taking time to do analysis before you go out and just fix the problem, which kind of goes back to our original mentality of trying to be more proactive instead of reactive, right? And because they were brought in this process from the very beginning, in fact, most of it is their idea, they never felt that it was trying to force down their throat. You know what I mean? It was very organic, and they were one of the biggest drivers of adopting this technology and these capabilities. So, but why does the management care? Well, at the end of the day, it's more data collection, which allows for better resource allocation, which allows better analysis. All you guys know from managers out there that the boards and your general managers, they love pretty graphs. And so it's able to paint the picture. It's able to provide a predictability, and it's able to, by doing all those things, it really is able to reduce risks and make better decisions. And I'll elaborate that here in a second. So again, we talked about predictability, but what it really does is it's saving time and it's saving money. And you can take my word for it, but there's a lot of methods that it's done, and mainly through the route optimization, less fuel because there's less back and forth. Now you're talking going from one end of the district to the other end of the district. That could be a round trip of almost 60 miles. And if you minimize those trips, you can see where those little tidbits start to add up, both in time and money. But here perhaps is the most interesting point. Because we were able to collect data for a preventive maintenance plan, I was able to run some interesting analysis on that. I'll show you here in a second, but we were able to, on average, I divided up our maintenance into basically 3 sections. Similar to a budget, you're going to have a variable costs and fixed costs. Well, that's the same for our time. And because the software allows us to collect that, we're able to see where we're saving our time and money very specifically, both geographically and also functionally. One of the things I was able to do was to collect the data points where we did not do preventive maintenance and what that cost us had we done it. And it was actually a total of 15 data points, which you're going to see here in a second what those results were. And on average, it was about 3 times more expensive to do unpredictable maintenance as opposed to preventive maintenance. And by what I mean unpredictable maintenance is something breaks, we go fix it, right? Preventive maintenance is you fix it before it breaks. And on average, if you wait for that, just like if you're going to do that for your car and you don't change your oil, replacing your motor is a lot more expensive than changing the oil, right? So it's very similar with us. But there's some second and third order effects which really improve some communication because it's a real-time common operating picture, and that cannot be said, emphasized enough. Where in the past there was a big time delay because everything had to be either manually entered or it was done via pencil and paper. So not only do you have multiple manual entries, but you have time delays to get that information. Here, it's as minute as something is done, it's already captured and it's already broadcasted to the entire network. And of course, it improved our record keeping and tracking. Bottom line, more data equals better decisions is really what it boils down to. And let me show you what those decisions came back. So I want to emphasize, because we had the GIS, we're able to really collect that data where we can find what these results were. And relatively, it took a very small investment of our time and money, right? So about 10% investment of our time, as you see here. This is what we spend on preventive maintenance, about 13% of our total budget, and you're going to see what that results landed us. We're able to do the preventive maintenance plan, and prior to this year, we weren't able to do any of the preventive maintenance plan. Well, I shouldn't say that. Very little, very, very little, and we weren't able to track it. So because of that, we're able to do 39% more work orders for critical infrastructure and 32% more work orders on the total across the district, which we would have not done otherwise, and that's given the same budget. So again, very small investment turns into very large savings. So I actually, as I mentioned earlier, with that 3-to-1 ratio of what it costs to save, waiting to fix something as opposed to fixing it before it breaks. So we ran some numbers, and for the 15 data points that we had failures, these are places where we didn't do preventive maintenance. And again, this was not due to the lack of effort on my operator's part. It's either due to a lack of time, or we just didn't get around to it, or for whatever reason. But it would have cost us about $65,000 to do the preventive maintenance. We ended up spending almost $285,000 to fix it because things broke, right? So if you do the average across those 15 data points, that's a ratio of 3.12, right? So if we extrapolate that, that's the bad news. That's where we did not do it. But let's extrapolate it one step further, and let's look at the good news. The good news is where we did do our preventive maintenance, we spent about just over $340,000 doing preventive maintenance elsewhere, right? So we did a lot more than we didn't do, and I'm very confident we're going to continue that trend in a positive direction in the very near future. So if we assume that ratio at 3.12, and we very simply multiply those two numbers together, we get a cost savings of over $1 million, and that's under just 9 months alone. And again, these numbers don't represent the cost of implementing the GIS. That is not really kind of part of this equation. But what the GIS really did do was it gave us the tool to find these numbers in the first place so we can properly dedicate the right resources to provide those cost savings. So in the end, really, it's a very relatively small investment of your time and money yields a very big results. I mean, 10% of our time and about 13% of our budget yielded almost 40% more work complete in the savings of an estimated over $1 million. Is really what that boils down to. The GIS was the tool that allowed us to track and monitor that status and find where to invest the resources for the biggest savings. So in conclusion, today we're much more proactive than we were a year ago, which is a good thing, and we're only getting better. This really is only the beginning. There's a lot of things we have on the horizon, like we'd like to further use data and or the kind of catchphrase of the day is the big data, right? So we want to go from, right now we've kind of shifted from reactive, we are much more proactive, there's work to do, but the next iteration is to go from preventative to predictive. And that's going to require even more data and some even artificial intelligence and learning logic to do that. And there are some programs that do that, and there are some programs that do that within the confines of the GIS. An example of that would be I'd like to integrate our GIS data with some of our SCADA data. And for those of you that don't know what that is, that's the automation software that we use across the district. It's pretty standard used along the water industry. I'd like to integrate it using hydraulic models for more engineering assessments. I'd like to make that information available in real time to the operators as well. And GIS is kind of going to be the key linchpin to do all those things. So that kind of wraps it up for me. And I hope you all have enjoyed that. Here's my contact info, and feel free to reach out to me at any time if you have any additional questions. And with that, I'll pass it back to you, Krista.
Thanks, Eric. It sounds like you're doing a lot at Camarosa Water and definitely looking to do more.
Oh yes, very much so.
So we did get several questions come in during your presentation, and we are going to get to those right now. First question, how are you linking those as-builts? There seems to be a lot of interest in showing those as-builts to your field crews and making that available to them. Was that difficult for you to do, or it wasn't such a difficulty, and are they really using those as-builts?
You know, I'm glad you asked that question. I can tell you that my knowledge of that is very surface level. I don't have the magic. To me, it's kind of black magic, but we have a very talented technical staff that's able to do that. If you give me a call, I can link you with that. But I do know that there is a database in where we store all the as-built, and that is linked directly to the asset ID for the GIS, and then that is then forward broadcasted on that program that I just showed you right there, which is the kind of the front end to that. To the field guys. And the second part of that question is if that's used. That is an unequivocal, absolutely yes. That's used probably daily, and that's probably that from the operator's perspective, that's probably their absolute most favorite part of this presentation for sure, and even the GIS capability, because the ability to not have to come back to the office to get an as-built is enormous. It's huge, and it's not a data problem because it's being broadcasted out. So you don't have to have these computers with massive storage capabilities in their possession. So every as-built you can do, you can look from your phone or you can look it from your tablet.
Very good. Thanks, Eric. I know that you can link to images within your Geodatabase, so maybe that's how you have it set up. Moving on to a next question is, when you were implementing the applications, you said that your team was involved quite a bit in communicating what they would like in the field. Was there a certain level of training that you had to provide to them, and how long did that take?
No, there was no real training. Again, we have a very bright O&M staff. And actually, surprisingly enough, it was actually our older generation that was kind of pushing for it, which is probably counter to most districts. What you have to do is you have to be very cognizant of human beings are really good, consequently, at not telling you what they want, and they're really good at telling you what they don't want. So you have to, I want to say you have to have the translator in place. And sometimes that person was me, sometimes that person was the operations superintendent. Sometimes that person was the operators themselves, but you have to, it's a lot of cross-talking back and forth so operators can understand what the capabilities are, and then conversely, the GIS staff has to understand what the operators go through day in, day out. I will say what helps a lot is we do a very good job here at cross-training across the board, but one of the things can help very easily is just doing, if your GIS staff takes field trips with the field operators so they understand when they're, fixing that pipe at 3 o'clock in the morning and it's cold, dark, and damp, the last thing they want to do is wait for a web page to load, or have to go in and type it into a computer. They want it right then and there. So understanding the environment that everybody's kind of working in really is what I would call the training. I like the term topical empathy.
Great. Thanks. We have a couple of questions that are pertaining to your GIS staff. So it's a little bit of a two-part. The audience is asking, how many staff focused on GIS did it take to implement this, or was the GIS work managed by a third party outside of your organization?
So we had, at the time, one full-time GIS employee and a part-time GIS employee who is now, consequently, the part-time employee has now been brought on full-time. And we're bringing up another part-time. So it was, I'd say, 85% done in-house. there was some coordination. That application you saw was done by a third party, and that's kind of the front end. That one is called Mobile 311. There was some coordination done with them. But as far as the GIS stand-up, I do have to caveat this. We were fortunate that when we had the GIS, we had a pretty robust GIS in play. And that took several years to get to that. And that was primarily that one individual, working around the clock to get our GIS to where it's usable and accurate enough, right? I do know that and this is before my tenure, but several years ago, we did use a third party to go out and collect the data for us out in the field. But most of the GIS hookups and the network within the computer was done in-house.
Thanks, Eric. That's a great segue into the next question. So you mentioned you did have someone several years ago go out into the field and collect data for you. One of our attendees would like to know about data collection, specifically to using GPS to create locations for your features. Is this something that you've continued? Do you use any kind of GPS units?
Absolutely. I don't know how you couldn't. So originally, most of GIS was developed using as-built, right? But of course, some of those as-built could be as old as 40 years old, well before GPS was even invented. But we've actually found that they're pretty accurate because they were done with local, the most modern surveying techniques at the time. There was some technical things we run into, like datum conversions and stuff like that, which we were able to get through those hurdles. So a lot of this stuff we've done it's kind of a two-part question. One, they're built with as-built, but then they were confirmed later on with sub-centimeter level GPS units, and some of that stuff was contracted out. And then the second part is we have multiple Trimbles out in the field right now, so when we do find errors, or there's, like, for example, a new construction layout or a new housing tract going in, our inspector goes out and he has a Trimble that he will collect the data as something new is being placed in the ground, in which case he will put in the work order in Collector to put that and update the GIS afterwards. So there's two parts. One is the initial creation, and the other one is the upkeep. And we have a system in place to build upon both. And the answer to the GPS question specifically is yes, we unequivocally, absolutely use as accurate of a GPS as we can.
Thanks, Eric. Moving on a little bit, focused on Collector, you've mentioned it a couple times, and I know it was part of your presentation. A couple of our attendees are asking about licensing. So being at Esri, I know that to use Collector, you need to have an ArcGIS Online identity. I would assume that your field staff has to log into ArcGIS Online and then they get to use Collector. Can you talk about that a little bit?
Yeah, sure. So we have multiple Esri licenses, as Chris, so you're well aware. We have we use ArcGIS Online, but we also have multiple licenses for the other one.
Desktop.
What's that?
ArcGIS Desktop.
Yeah, desktop, and then I kind of wish our GIS guy was in the room right now because he would know this off the top of his head.
ArcGIS Server.
Server, thank you. That's the one I was thinking of. Yes. So we have a couple desktop licenses, a couple pro licenses, server, and then ArcGIS Online, and various applications use various licensing requirements. So I believe right now for our staff we have 10 licenses, which works out pretty good because we have about we have approximately around 10 to 12 operators, so it works pretty well.
Great. Yeah, that Collector application really makes the field data part easy, and having ArcGIS Online is a quick login. So each operator that's using Collector for the audience would need to log in using ArcGIS Online.
Right.
So
if you email me directly, I can elaborate on some of that and get you to the right person.
Thanks, Eric. You're so nice. I saw you shared all of your contact information, so that's amazing. I often get emails after webinars asking me if I can connect attendees to presenters, so that's really great that you shared that ahead of time.
Sure.
I think we're going to do one more question, and this one's a little bit of give all your information here. It's an open question, but if you could change anything about how you implemented this and interacted with your operators, what would that be? Was there anything that you think could have been changed that would have improved the process?
I mean, there's always something we can improve upon. I can't think of anything right now off the top of my head. There's some capabilities that we would have liked to have from the get-go that we don't. One of the capabilities I don't have right now, and actually one of the things we're working on, is I want to start using the dashboard function. And there's some technical hurdles based on how we collect the data why that hasn't happened yet. But we are working with actually a third-party contractor that's for the integration of that. So there's some technical things, sure. Mainly for me, it's some of the reporting functions. But I would say that I think we did a very good job of getting good buy-in from the operators because really, I think they were the ones kind of driving this, and I was just more facilitating that role.
Okay, great. I know that you're really happy with how it's going so far. So we might need to check back in with you later in the year to see what you've accomplished. We have a couple general questions about the presentation and the webinar. So for those of you that are still on the line, yes, we're recording this webinar. It will be made available online. It'll take a couple days, so probably next week it'll be online for you to view again if you missed parts of it. And then Eric, really quick, these questions just keep coming in. One more short one. This one's easy. The devices that your operators are using in the field, can you talk about that? Are they iPhones, iPads?
Yeah, sure. So we did make sure ahead of time that everything is compatible with everything else. So with one exception, so right now all the operators they all have tablets, and they're all Galaxy, Samsung off-the-shelf tablets. And they also have cell phones, which are Galaxy, Samsung off-the-shelf cell phones. So they have that, and then there's a desktop version that we use for kind of the front end of the software. There's some server stuff that I'm not privy to. I could ask the question, but I don't know off the top of my head that I can answer. But as far as operators, they pretty much have tablets, cell phones, and then they also had legacy atlases, which are generated from the Esri Geodatabase, which makes it really nice because in case we ever were to have a power failure or anything like that, they still have the legacy capability. And we did check that it is all compatible with Apple. Like Galaxy just was the one we chose, and the one exception is we have our inspector who uses a Surface Pro, and we've had some issues with that. He can still use it, but he has to use kind of the desktop version. There's some apps that it doesn't support. So the Windows products have not worked as well.
Thanks, Eric. I know we've asked you a lot of questions. I really appreciate you presenting today. I know you mentioned multiple times that you are the operations manager, not the GIS guy. So I really appreciate you. A brave answer here for you to face all of these people asking specific questions about the software. So thank you so much, Eric.
Sure, no problem. And again, any questions anybody may have, just feel free to email me or call me, and I'd love to get back to you.
Right, and Eric's contact information will be included as part of the recording. So if you missed that, watch for the recording or shoot me an email and I can forward it to you as well. Thank you for joining. We hope to see you next time on our Esri Water Meetup.